Okay, so last time we stopped at looking at the distance formula with the equation of a circle. So today, before we get started on the next review, I wanted to actually just talk about some algebra, an algebraic technique. So this is called completing the square. So how do you complete the square, and what is the question asking us to do? So we're given something of the form, let's say ax squared plus bx plus c. And the idea is you want to convert that expression to the form. I guess we'll have an a there, and then we'll have x plus, maybe I'll use a c hat squared plus d hat. Okay, so this is the form that we get for completing the square. We want to move from here to here. Okay, because this actually tells us how to plot the parabola. And so this form is sometimes very useful. It also allows us to invert the formula, but we'll look at that later. So let's just do a quick example. So if you have a leading coefficient here in front of the x squared, go ahead and factor that out. Otherwise, we can leave it. And so let's go ahead and write, how about x squared plus 2x plus 4. I want to convert that. I want to complete the square to convert that into this form. So the way to do that is to rewrite it x squared plus 2x, and then we're going to add and subtract something. We're going to add and subtract the same number so that we get a perfect square. So what number goes into this position? It turns out that it's half the middle term squared. Let me write that down. This becomes half the middle term squared. And if we use that number, that's going to give us a perfect square. So in this case, we have 2 divided by 2 is 1, and then 1 squared is 1. So I'm going to add 1 and subtract 1. And so this becomes, the perfect square is the half the middle term. So that's going to be x plus 1 quantity squared plus 3. So this is the end result of completing the square. And we've converted this expression to this expression. Good. Let's try another one, just to be sure we got it. How about x squared? Oh, how about 2x squared plus 3x? We'll get some fractions in here, plus 4. Okay, so first we want to pull out that 2. So then we'll have an x squared plus 3 halves x plus something. And then we'll have the plus 4 on the outside. And now, half the middle term will be 3/4. Squared would be 9/16. And so we're going to end up with 2 times x squared plus 3 halves plus 9/16. But when you write 9/16 here, 9/16 here, notice that what you're actually adding in there is 2 times 9/16, which is 9/8, right? So you're actually only adding 9/8 to this expression. So that's the expression that we would subtract. Oops, let me go back to the white pen here. 4 minus then 9/8. Good. And so then we get 2 times x plus, that was our 3/4 squared. And then let's see, that's 8/8 minus, or sorry, how many is that? That's 32/8. What's 32/8 minus 9? It's 23/8. So we'll have plus 23/8 on the outside. Okay, good. So now we've got our perfect square. Good, and so that's how the perfect square works. You might try a couple for yourself in the text. Good. Maybe while I'm here, I've got a little bit of extra time. Maybe we can do another complete the square problem just to be sure that that's okay. So suppose I've got, we want to solve let's say x plus 1 times x minus 3 divided by x plus 2, and I want that to be a positive number. Okay, so the way we use the sign chart is that we'll list the factors. In this case, we have 3 factors: x plus 1, x minus 3, and x plus 2. We write those to the left, and then underneath we have the number line that we're going to be checking. And then on the number line, you want to write where each of these is equal to 0. So this first one is equal to 0 at -1. And so break the number line at -1. The second one is, oops, I'm going to need a little extra space there. Let me put -1 over here. And then the next one is 0 at 3. And the next one is 0 at -2. Okay, and so what happens is that these numbers break the number line into different regions. And so now we just go through and we take a sample point out of each region and we plug it in to each of our factors, and we see if each factor is either positive or negative. There is a little bit of a shortcut. So for example, here with this x plus 1, I know that it changes sign at -1. So therefore it's either going to be all negatives over here and all positives over here, or vice versa. And because that's a positive slope, right, that's going to be negative, negative, positive, positive. And for x minus 3, it'll be the similar thing. It'll change sign at 3. It'll go from negative to positive there. Negative, 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 positive. And you can double check those. But this is just a shortcut. X plus 2 is going to be negative, and then positive, positive, positive. Good. And now we can see which regions will satisfy the original relationship. So in this region, right, we'll have a negative times a negative on top. So that would be a positive in the numerator, negative in the denominator. So overall, this would be negative. So that doesn't work. Here in the region between -2 and -1, we have a numerator that's positive, denominator that's positive, and so this is going to be okay. In the next region, we'll have a negative in the numerator, positive in the denominator, so that's not going to work. And then finally, we have all positives, so that's going to work. Okay, and so to express the answer, right, we would have x is between -2, -1, or x is bigger than 3. Now, can we include any of these points? Can we include the number 3, for example? We can't include the number 3 because we don't have a greater than or equal to here. Right, it's just greater than. So therefore, we would leave those endpoints out. And we would also leave out the -2, right? Because that would make our denominator equal to 0. And so this would be our answer. Good. So that's just a little extra problem just to see how you're doing. We'll get on with the regular review in the next section.